Good morning, everybody. I'm going to make the first presentation of the day, and it's about virtual and augmented reality and the use of virtual and augmented reality in culture and specifically in museums. I'm going to present it through a work we have done in the museum we have, in telecommunication we have in the Universidad Polytechnic de Valencia. So this is
sorry, Carmen, I would like to, sorry, I will interrupt you. I had some problem to hear you correctly.
Oh.
I'm not sure if it is because of your connection or my connection. I would like to ask other participants if the connection was okay for them.
It's okay for me.
It's okay.
Very good on this side.
Okay, so I used the cable to connect. So I would like to ask you to start again.
Okay. I am presenting then the table of contents of my presentation. So then we will have a short introduction about what is virtual reality and what is augmented reality. And then I will present our case study, that is how we have used virtual and augmented reality in the Telecommunication Museum, and then some results and conclusions and time for questions. So what is virtual reality? So virtual reality is an environment that you have created completely artificially, that you have created that in a computer. And the objective of that is to have or to create for the user the feeling of having inside this environment, of being inside an artificial environment that you have created. The idea is that this fictitious world seems as real as possible, because we wanted that the user have a complete experience of reality. There are two types of virtual reality: immersive and non-immersive. And in the immersive one, you use different methods to approach to this immersion in the real, in the 3D environment or in the virtual reality. You can use helmets, glasses, gloves, or other devices that help to manipulate the environment that is generated by the computer. And this adds more feeling of immersion, because you feel that you are really inside the environment because you cannot see the outside the environment. In the contrary, non-immersive virtual reality only use a keyboard, or mouse, or a screen. That is the usual way we are used to interact with the computer. Of course, they are more accessible and cheaper. So these are two examples of immersive and non-immersive virtual reality. On the left, you have a driving simulation that using glasses and a steering wheel to have the experience of driving a car. And on the right, you have a 3D view of Google Maps. That is an example of non-immersive virtual reality, because you can see the reality, the virtual reality, but you only see it on a screen. For virtual reality immersive technology, the one that we have used in our experience in the museum, we have used Unity and Oculus technologies. Unity is a video game engine. There are other video games engines for sure, of course, but this one presents for us some advantages. Well, it has licenses for Windows, Mac, and Linux, but it has free licenses for personal or teaching use as university projects. So it's quite interesting for us. It uses C# programming and supports several APIs, Direct3D for Windows, OpenGL for Windows, Mac, the operative system of Mac and Linux, and in addition of other iOS and Android or other video game platforms. You can develop content in Unity for either computers or smartphones or tablets. And Oculus is a virtual reality technology company that was founded in 2012 and purchased by Facebook. And the main and the best known product are glasses. Oculus Rift is one of the most sell glasses in the market, and as well as other Oculus glasses are the Oculus Rift S or Oculus Go or Gear VR. So the idea is to complement these Oculus glasses with the Unity video game that was created. And the glasses also use tracking sensors, touch controls, and they are similar. The controls are similar to the controls, the commands of the Xbox console. So it's quite easy to use for generations that are used to play video games. So this is an example of the Unity and Oculus pack. You have on the one side the Unity environment where you create your virtual reality, and then the Oculus pack where you can watch it or experience it. Then, what is augmented reality? Augmented reality is different because in the augmented reality, there is the reality is completed by other information. You can have different multiple sensors that track the reality, and then you include several different experiences. That this experience can be a visual experience, audio experience, haptic experience, somatosensory experience, or olfactory experience. The idea is that the augmented reality always have three main features. There's a combination of real and virtual worlds. There is a real-time interaction, and there is also an accurate 3D registration of virtual and of real objects. The idea is that when you interact with an augmented reality system, you can have your experience, your real experience, enhanced by other things that can be created for that time. So this is an example of augmented reality where you see a picture, or well, you use a tablet to focus a picture, and then this picture can be alive. So which areas of application are for augmented reality? There are several areas of application, as much as you can imagine. For marketing, for entertainment, for education, for industry, for tourism, and for culture. And in the specific case study we have here, we have used it for museums, that is for culture. So how it works, more or less. So we have used three different software tools or development tools. On the one hand, Unity, because it's multi-platform and it has good integration with other systems, and it's worth to say that we had a previous experience of that. Then we have Vuforia, that is a software development kit to manage elements of augmented reality. It's an augmented reality engine. It allows you to track and recognize images in real time and also to trigger the augmented reality events. And then Visual Studio, because we use in some parts of the applications, you need to use C# code or any other code that you can to program any pieces or any parts of the application. So there are other augmented reality engines. For example, Apple has the AR code, and Google also have the AR kit. But we prefer Vuforia for some issues. So it has, or some issues, some characteristics. It enables multi-platform development. It can be implemented in a wide range of devices, and also provides the support, if the device supports it, to the other technologies. And it was implemented for a longer time, so there is a big community and there's a lot of information, and this helps a lot to the students that want to develop something in augmented reality. And also it has a free license for developing in the teachers or in non-professional environments. So how it works? So first you have a target that can be an object or an image, and then you have to focus this target with your smartphone, for example, or your tablet phone. And then there is a tracker inside the engine that detects coincidence of the image or of the objects and detects this coincidence with a set of images or objects that are in a database. And with it detects this coincidence, so it triggers an event of augmented reality that can be a video or an animation or an audio. There are different ways to make this detection, or that there are different ways that in which you can make an augmented reality application. You can be based on image tracking. So you have an image, and this image is recognized by a set of pixels that are a set of features that you have stored in your database. So this was used, for example, in this example, you have the envelope of a video game, and when you picture it, or when you focus it with your camera and your application of augmented reality, so there is a recognition of that image, and the event can happen. For example, a demonstration of how the games work. Then there is also another way to recognize, that is using what is called VUMarks. VUMarks is a kind of next generation of barcode. In a VUMark, that is mainly like a QR image, the traces for recognition are enclosed in a logo or in a trademark. So you have these traces for recognition, but they are enclosed in a logo, or these traces for recognition that they are enclosed in that logo, or the same here. So it's a way to create a QR, but that has not the appearance of a QR and can be more specific for your product. Then you also have what is called model tracking. What you have is to have an object and to have the model of the object, and then, like you can see in the image, to see or to focus one on the other and create the object on the screen and let it do something. In museums, it is used to show a restored version of a damaged item, for example. That is very useful. There's and there are other features like object tracking or ground plane. Object tracking is quite similar, but you don't have of the model tracking, but you don't have a model of the object, but you have the object itself with a lot of rich surface details, and the object has to have a very consistent shape, because otherwise it cannot be recognized. And in the ground plane, what you do is just create something on the ground. What is detected is just the ground, just the floor, and then you create something on scratch, for example, a building or the Eiffel Tower or whatever. Augmented reality, the current application of augmented reality have some disadvantages. For example, you can have a very good light estimation, because everything is working on the image you get with the camera. So if the light changes, so the image will be changed and it will not be recognized. If there are reflections in objects, so it happens just the same. So for the camera recognition, it's just that the object is not the same. And then there's since it is an object that you have to handle by your hands, a mobile phone or a tablet, so your hands are moving. No, your hands are not steadicam, and there are some vibration and some stabilization of the objects are needed, because otherwise you can get a bit sick of that. And now I will present my specific case study. That is what we have developed this in the museum. So I will present first the museum, just to have for you to have an idea of what we have and what we needed, and then how we have developed this virtual reality and augmented reality in the museum. So the museum is in the Escuela Técnica Superior de Ingenieros de Telecomunicación. It's the telecommunication school of the Polytechnic University of Valencia. And it's 30 years old school. We have 1,100 students and 150 academy. And we teach there telecommunication degree and master, and digital and multimedia technology. So our areas of expertise are electronics, electromagnetism, optical, communication, telematics, signal processing, digital and multimedia system. And you can understand that the conservation of the technological heritage is not a priority. We are not a history academy. So nevertheless, this is an example of what we are and what we do. But nevertheless, we had a collection of items of telecommunication. And now our collection of items of telecommunication is of more than 700, and it's a big collection. And it's a collection of items of the 19, 20, and 21 centuries, and includes telegraphy, telephony, audiovisual equipment, radio communication, instrumentation, a library. So it's a big collection. Indeed, we are an official museum, and we have the duty to conserve, to restore the items, but also to show it to the society. This is an example of our items. As you can see, this is some telegraphy items from 19th century, telephony items, radio, and audio items, radio communications, some military radio communication, a lot of military radio communication also, some laboratory items, and the library. So to show the library, we have quite old books of telecommunications, as you can see here. And we first managed this collection in the halls of the building, because we didn't have a specific building to have the museum, and we distributed in 5 sections: telegraphy, telephony, audiovisual, radio communication, and instrumentation, and we have an itinerary to make the visit. We have more or less 300 items exposed in display cases, in some display cases with glasses, and just to be them saved. But the museum has a pedagogical purpose. The idea is that students come and see the items and get interested by the telecommunication, but not only students of telecommunication, but younger students, school students or secondary school students. But how to make this more attractive to the visitors? Because the experience says that a 15-year-old young boy is not very interested by telegraphy, maybe. So you need something that catch their interest. So we prepare some documentation, posters for the showcase, we scanned all books and put it in the website. We made a catalog, we made publication, we made brochures, we made even videos, didactic guides, and so on. But nevertheless, it was not catching enough for these young visitors. So we make this virtual reality application. The virtual reality application can give you the experience of being inside the museum. You can see here a picture of the real museum and a picture of the virtual museum. And you can see that they are quite similar, and also you can activate the multimedia content of the augmented reality in this virtual view. And this is not just for the visitors of the museum, but for people that cannot visit the museum. They can have the experience of being inside the museum, even if they are at home. I think it's quite interesting, especially now with this lockdown problem, for example. And concerning the augmented reality, the idea is to provide some more or some additional information to the visitors, because we have a lot of different items, and these items used to work and used to make things for communication, but some students, young students or young people do not know how a dial telephone works, for example, or an old radio, how it sounded an old radio. So we developed an application for mobile telephones and with the features of an augmented reality. We have a static part of the application where some activities, short video of presentations and information is content in this static part, and then we have the augmented reality prototype. In the augmented reality, we have 15 different objects: telegraphs, magnetophs, dial phones, crystal radios, phonographs, old televisions, black and white, switchboards, a lot of things we have. And we wanted to show how they work to the students. And since we had the problems of reflections of light, because as I mentioned, the objects were stored in display cases, and we have a lot of reflection of different lights, we have to develop marks, for example, a boom mark. And we developed this visual mark for tracking the objects. And these are some examples. Here we have a manual switchboard, and with the augmented reality, you can see a telephone operator working in this switchboard. Or we can have audio events where the speaker shows you that there is an audio that you can listen. This is an old telegraphic station, a radio station, so you can just hear how it was hearing with an old radio station. And then we made a survey to get some results and some conclusions. So we made a survey for the augmented reality application. We get students between 12 and 13 years old. They download the application, they visit the museum, and then they made a short test. The test have two parts. One was objective, just to detect failures or performance problems or whatever, just to improve the application. And the other one was subjective, to get the feelings when using the application during the visit. So, and the results of the test was very good, because the level of satisfaction, that is this one, was very high. And just for finishing, because I don't know which is my time, if I don't know if I am inside time or not. Just for concluding, so saying that
8 minutes.
The technology, the technology is mature enough to provide viable applications, but there are some limitations that to be considered if you want to develop an application of virtual reality or augmented reality. Concerning augmented reality, you have to take into account that the lights, the reflection, the vibration that we have to complete for different operating systems. There are some technical limitations. And in virtual reality, you have to take into account that polygonalization and a lot of computer processing requirements that you will have. And also you have to compile the same application for different virtual reality glasses. And there are also some issues that for sure can be solved, but that you have to take into account just previously or just before you face this process of developing an virtual reality or an augmented reality application. On the other hand, there is a need to produce and to select this audio and visual content you will have to have in your application, because it's the key elements for enrich the visit. So if you do not have a good set of audio content or visual content to show, there's no need to make the application. And even if you have the know-how and infrastructure, so it takes a lot of hours of programming and content creation, such as graphic and 3D models, to make this application viable. So for creating this kind of application, you will need a team, not only of technical staff, but also of artist staff to create this content. And I think that this is everything from my side. This is time for question if you want. So.
Yes, thank you very much. I think you still have 5 minutes, so don't worry. So yes, please. I would like to give a first question. I can imagine that these applications can include geographic information, some location.
Well, it depends. It depends. They can include geographic location if you want to include them. But if you just want to create, for example, for the augmented reality applications, if you just want to create a content to enhance an object, you don't need this geographic information. You just need the object or the mark that says that this object is there. So no, it's not a need of having a GPS implementation in that.
Yes, I think it could be independent. I am thinking about, for example, I am in hiking, and I can read some information, some boards. I am near some ruin of former castle, and using this augmented reality, I can see how it looked 500 years ago. So
you will you will need you can have this tracking with two different. Well, with several, but mainly with two different approaches. One can be the recognition of the object, pointing in a place where you can see the object and you can recognize it, or you can have a mark. So if you have the mark, there is not a need for this geographic information, but the application can include the geographic information to show where the mark is.
Mm-hmm. Okay.
So it's a different thing. For example, we are now developing an application for the outside. We have in the campus, we have a sculpture museum, outside museum. And in our campus, there are a lot of sculptures, and we want to create this application, augmented reality application for this campus museum. That is an open air museum. So on the one hand, we have in the application the location of all the sculptures. And for that, we need a geographic system location and in a map to track it in a map where each sculpture is. But when you are in front of the sculpture and you want to trigger the augmented reality event, it is not triggered because you are in a position. It is triggered because you track the object or track the image that represents the object.
Yes, yes. Okay, thank you. Now, Klaus, you have a question?
Yes, my question is, what are the technical infrastructure requirements? Let's say you have a very small museum, normally they're not equipped with Wi-Fi. Is it done only by 3G, 4G, 5G? So, I mean, every time the handheld, I mean, the mobile phone, tablet, takes the picture, it needs to be transmitted to some kind of computer.
No. This can be this can work with no connection. So if you have,
so you download all the information with the app.
Yes. Well, it depends. You can there are two different approaches. You can download all the information in the app.
Okay.
With the videos or the images and so on, and just take into account that since you are going to watch it in the smartphone, you can have low quality videos. So yes. It's not so heavy.
Okay. Okay.
Or you can have also animations that are that can be low quality.
Low resolution, yes.
Yes, low resolution. So they are not so heavy. And then you download the application.
Okay.
Then there is another option that is to have the database in a server and then to make this transfer. But these have some problems of
connectivity,
of timing.
Timing.
Yes, of response. Because the idea of augmented reality is that you have an immediate response. You are with your tablet in front of an image, and then that image pops.
Right.
And something happens to you. And this immediate response is what is how to say.
Well, you need 5G.
Yes, but it is this is the idea that sometimes or in some way surprise you. And in other museums, for example, I have seen it in the Rome. In the Arapakis Museum, that is a ruin of Rome. Well, it was the tomb of the Emperor Augustus, so something in Rome. So it is a very nice building and sculpture, and so that's impressive thing of Rome. And it is made of stone, but it used to be painted. But now you cannot see any painting on them. So you go in the museum, you pay some extra, you get this tablet, and then you go with the tablet in front of the sculpture, and then you can see them paint.
Okay, thank you. I'm sorry, I have to finish our discussion.
Okay.